Welcome back to Corey Rawson, and I want to talk to you about two pages I have here with the qualitative analysis of 9 white powders lab. Did a lab just like this pretty much, maybe most of us did. When I was in college, this would have been the second or third lab we did. We were trying to tell white powders apart. And if you get this paper from me, it's first of all, you could probably find better ones, but the first page, the only thing you need is to fill out those 9 powders. You really don't need all this text. This is actually, I think, 2 different sources for the same lab. This flow chart here is why I like to do this. Now, this lab, I do in, classes that aren't even chemistry. For example, I do this in my engineering classes because if you are going to be an engineer, you're going to be doing some troubleshooting. And if you're troubleshooting, you're going to be following your own flow chart or somebody else's, either formally or informally, where is it this problem or is this problem? Is it this problem or is this problem? And you're going to work your way through by process of elimination until you've figured out what the problem is. So if your students have to work a cladistic key or a taxonomic key or do any kind of flow charting or troubleshooting, this is a great, it's the same skill, it's just in chemistry. So even though it's a chemistry lab, I use it for other things. There are 2 pages on here. Mary Lou Altenberger from Fort Jennings, if you knew her back in the day, she died about 15 years ago, I would say, gave me this, and so I want to pass along that kudos to her because I know I did it in college, but this is a really good lab for even middle school kids. I've done this with middle school. But when you do it, there's some issues. Here's one that I've run into. Let me put a little bit of cornstarch in, and I haven't previewed to know what this is going to do today, but I noticed this recently. I mean, in the matter of weeks ago, I figured out what the problem was. If you put some cornstarch in here, and the kids wouldn't know this is cornstarch, but you're doing the test for cornstarch, and you put the other chemicals in there, you're going to get brown. Hang on just a second. I forgot my water. You're going to get brown on the other chemicals, but sometimes you get brown on the cornstarch and you don't get a very good result. Now, it has been dry here for weeks and weeks and weeks, but it's a little more humid today, so I don't know what's going to happen. But if you put your iodine tincture, so this is iodine solid dissolved in ethanol, and it might depend on the alcohol you got, and you pour some in there on your dry powder, I don't get any brown result. I mean, I don't get that purple black, okay? Because it needs a little moisture. I didn't know this. Just give it a drop. And you may see that come up. See? Just give it a little bit of moisture and that purple black shows up, okay? Just a drop is, I put about 3 drops in there and it's too many. I don't know the chemistry behind that. I haven't looked into it. It might have something to do with the ethanol is just too water absorbent. It's too miscible with water. It's taking up the water, I don't know, and it needs a little bit of water anyway to do this. A little bit of water will give you the brown. So one thing I haven't tried that I think would work great is to take a spray bottle, that mist, and mist that in there, and I think it'll make purple as the vapor goes in. Okay, yeah, so I'm very thankful that Mary Lou gave me that years and years ago. I've used it many times. It's really a very good lab. And then if we go to the next one, the bromethymol blue test. I don't know what's going to happen with this today exactly. Nice strong ammonia smell. Bromethymol blue is itself a weak acid. So this is pretty typical. If you go to the image here, it's pretty typical for your titration indicator to be a weak acid. So it ionizes off of hydrogen. And when hydrogen ionizes off of, actually when bromethymol blue takes up a hydrogen, somebody else's hydrogen, it turns yellow. So what I'm trying to show you with this is the bromethymol blue wasn't working. So I took the lid off, put it in this jar, put some ammonia in with it, which, by the way, the ammonia will dissolve the lid, so you gotta be careful. And I set this back to blue because it was changing color. It was only giving me yellow, so I'll give you an example of this. Okay, let me talk about something else, litmus. There's not blue litmus paper and red litmus paper, there's just litmus paper. And if the blue litmus paper and the red litmus paper aren't very much different, you can put a vial of blue litmus paper in here with the lid open and put it in there with ammonia and close it up, and it will turn blue within seconds. It will restore it. You can put another container like this with concentrated hydrochloric acid in it, vapor, where it'll be straight out of the reagent bottle where it'll make vapor, and put a lid on it, and that'll turn it red. So you can reset your litmus too. There's not two different kinds of litmus. Nobody ever tells you that. You'll figure it out on your own. Anyway, so I put a little ammonia atmosphere in there, and this probably takes a couple of minutes. I left it in there for 20, 30 minutes, pulled it out, and it still smells like ammonia. Okay, so let's go back to this. There's been many times I've been using phenolphthalein and it's barely pink, and I'm sitting there swirling it and the pink goes away. That's because it's picking up carbon dioxide from the atmosphere. We don't realize this in our reactions. It doesn't make a difference most of the time. But let's say you're picking up a few 100 trillion carbon dioxide molecules a second. That's nothing. That's a blip on the radar. But it's enough to push an indicator to change color if it's at the endpoint. So if you have a phenolphthalein solution that's barely pink and you're sitting there stirring it, it'll clear up as it's absorbing carbon dioxide from the atmosphere. Now, it's not going to work if it's not near the endpoint, but if it's at that transition, it'll push it over the edge. So this is distilled water that's mostly empty. This has been opened many times. Carbon dioxide has got in here, this distilled water. And I'm going to put some in here. And what should happen is nothing because I reset this bromethymol blue. But the problem I was having in the lab was I would put my bromethymol blue in here. Yeah, blue this is now. It's like cobalt blue almost. And I can still smell the ammonia with that. But I was putting the bromethymol blue in with the solutions, and the bromethymol blue was a couple years old, had been opened a whole bunch of times to get carbon dioxide in there, and it would go in the water, and I'd get yellow on every result. It's like, well, I gotta find a way to get that back to blue, so it's only turning yellow when I put it with boric acid and everything else. So it stays blue this way. And I had trouble with the lab at college, and I look back now, and it's because probably the same reason. Their bromethymol blue was already yellow because it had been opened, it got carbon dioxide in there, and it wasn't starting with the blue. So you can reset it to blue by putting it in a ammonia environment. And I don't have this prepared to do with you today, but yeah, you put boric acid in there with that, it'll yellow right up. The other ones won't. I have done that part. So thank you to Mary Lou in memory of her.